Okay, hey class, we're going to do lesson 7 now. Lesson 7 is all about the sum and difference identities for sine. So again, kind of a misnomer here. We're going to do sum identity, and I guess it's only sum identity 2 because we had sum identity cosine. Now we've got sum identity for sine. So the sine of a sum, alpha plus beta, is going to be sine of alpha times the cosine of beta. So that's a departure from the rule for cosine, because cosine was cosine cosine. So you might have thought that sine would be sine sine, cosine cosine, but it isn't. The pattern for sine is that the trig functions sort of alternate. It goes sine cosine, then it goes cosine sine. So sine alpha, sine beta. The other departure is for cosine. The operations were mismatched. If we had plus, then we had minus. If we had minus, we had plus. But for sine, the operations are matched. So the sine of a sum is a sum, and the sine of a difference will be a difference. So speaking of differences, our difference identity number 2 for cosine would be cosine of alpha minus, okay. All right, back that up. I obviously meant to say the sine of a difference rule would be that the sine of alpha minus beta. And again, how repetitious is this? But it's going to be sine alpha, sine beta, minus cosine alpha, cosine beta. And we can come back to these in a minute, but these are going to be the rules for tangent. But let's go do the sine ones first. Well, that looks ugly. Okay, so basically there's 3 problems on this page. We could do any of them, but actually those are classwork problems, so, well, I don't know what they are. Those were do it at home problems, if I ever posted the videos for the inverted classroom model that we were supposed to start, but we didn't, so my bad. But let's do these classwork problems. Sine of 165, if you watched the last video, then you know my advice is pretty much just always do 45. And then add that to whatever the leftovers are. So if you subtract 45, then you know you'd break this down to a 120 and a 45. From here you could evaluate. Using our new sort of identity, the pattern here is that you want to be doing sine 120 times, already screwed it up, cosine 45. And then a sum stays a sum. And we've already done sine 120, so it's time to do cosine 120. And sine 45. But this is going to look and feel almost exactly the same as the problems that we did for cosine. So evaluate this. Where's 120 degrees? It is 60 degrees away from 180. So it's the special angle that's sort of in this position. So the sine is the y-coordinate. The y-coordinate should be bigger than the x-coordinate. So that's the root 3 over 2 one. Then the cosine then must be the 1/2 one. But since we're in quadrant 2, sine will get to be positive because it's a y value that went up. But cosine's going to have to be negative because it's an x value that went left. So there you go. There's the 120s handled. And again, the 40... Wow, I wrote 50. Why would I do that? That doesn't make any sense. Both of those are 45. And if you don't know much, you still know that cosine 45 is root 2 over 2, and sine of 45 is root 2 over 2. And if this is a sum, still a sum. Alright, we're ready to just write our answer at this point. This is going to be root 6 minus root 2 all over 4. Which is an expression we've exactly seen before, but of course we have, because as I told you in the last video, there is literally only 4 new positions on the unit circle. I meant 8. There's 8 new positions on the unit circle. There's the 15-degree reference angles in all 4. There's the 75-degree reference angles in all 4. But how many answers are there? There's small y value, big y value. That's 2. And then there's the opposites of those. Negative small, negative big y value. And the x's are the same because, think about it, this is 15 degrees and this is 75 degrees. they're the same positionally as 30 and 60 are. Remember how 30 and 60 were literally the same triangle, just reoriented to where the coordinates were root 3 over 2 and then 1/2, and then 60 was 1/2 coming first and root 3 over 2 coming second. Well, 15 and 75 have that same symmetrical that same symmetry. I should just be saying they have that same kind of symmetry. So I don't know, shout out to what's her face, that girl from period 8, Sadie said, I don't know, I was talking to Sadie about something and she noticed something about how, of course, there's a symmetry between these two angles. There's an angle sort of running between them. And so there's a symmetry over sort of the 45-degree mark. That is what does it. 30 and 60 have that same symmetry. That's why their coordinates are reflected. In fact, everybody in the room should know this. Y equals x is the line over which inverse functions reflect, remember? And what's the deal with inverse functions? All the points f of x are xy. And what do you remember about the points on the inverse of f of x? Don't they literally reverse? Y becomes the x and x becomes the y. So that's what's happening here too. Even in trigonometry land, it's the same thing. 30 and 60 just have their coordinates reversed. Well, 15 and 75 just have their coordinates reversed too. Now what are those coordinates? I don't want to get too deep in a hole here, but the positive x coordinate here, the big one, would be the root 6 plus root 2 over 4. That's the biggest positive value I could ever get from a root 6 and a root 2, would be to add them together. The y value would be what? Well, I want to still be positive, so I guess I should do root 6 minus root 2 over 4. So somebody out there, again from period 8, what's her face? Eliza. Eliza was interested in actually just memorizing these things, right? Well, we can do that. Here they are. Here's the coordinates for a 15-degree reference angle in quadrant 1. What would these be if we were a 15-degree reference angle in quadrant 4? Well, the x wouldn't change. It would literally still be a root 6 plus a root 2 over 4. The y coordinate, though, wants to be a small negative value. So if you want to be smallishly negative, then take the little guy, the root 2, and subtract the root 6 from it. That'll give us a negative. Right? You could memorize these. I'm not saying you should. I don't even know why I went off on this tangent. I hope somebody out there gives a damn. Yeah, whatever. You know what? I'll just say, I think when I'm making these videos, I feel like I have infinite time. Obviously, all this stuff, it would be lovely if I could say this stuff in class, but in class, I think I'm too focused on just like trying to get a problem done, trying to get you guys through how to do it. And I think I do give a lot of background information in class too, but there's more. I mean, there's so much more that I could give. Again, you know, tell me if all this extra stuff is actually helping you to understand more deeply to the point where you think you might actually remember it better and do better. Tell me that. And if I'm just throwing you off and wasting your time, you can tell me that too, and maybe I won't do as much of it. Anyhow, goodbye. I'm going to keep moving on. We did 1. I'm very proud of us. 1 is done. Why don't we do 2? Oops. I don't know how to do 2. Bring 2 down here, and then just scroll down. Might be easiest. Went too far. Alright, so there's that. This thing here represents my face. Look, see, I put it here because where I'm looking I can't see my face. So that reminds me not to write in that area. And then this line tells me not to go too far down because I'll go off the screen. So I'll put that right here. Okay, sorry, I'm taking long, I know. Oh, and I don't need that little dividing line, so we'll throw that in the garbage. I don't know how. There it is. Okay, holy cow. So let's do this one. Let's do it quickly. How quickly? Well, Eliza, watch how quickly I do it. I draw my unit circle. 13 pi over 12, where's that? It's 1 pi over 12 past 12 pi over 12, so it's a 15-degree reference angle in quadrant 4. Its sine is negative but small. So who's negative and small? Well, I've got a root 6 and I've got a root 2. Root 6 plus root 2 would be positive and big. Negative root 6 minus root 2 would be negative but big. But you know what? Root 2 minus root 6, that would be negative. And not super negative, just a little bit negative. So there, I did it. That's the answer. Memorized it. I got the answer. I'm done. Now you're not allowed to do that, Eliza. You have to actually show your work. But make a mental note, children. Make a mental note. I said that's going to be the answer. This. Why? Oh, right. Click, separate, grab. Throw that over there. That's what I said the answer is going to be. Now let's see if we actually get there. Delete all this garbage. Alright, so if this question was on the quiz and you had to actually do it for real, then you would, of course, take this thing and you break it down. You would treat it as the sine of, geez, I don't know, probably a pi over 4, right? But a pi over 4 in the form of 3 pi over 12. And then clearly what you're missing is 10 extra pi's over 12. So again, I hope this is modeling how easy it is to actually break these down. Just always use a pi over 4 and whatever else you need. That's a really good way to think about it. Then once you've got it, now reduce these. This is 5 pi over 6, which is evaluatable. And of course this is our trusty pi over 4. So now expand this using the identity. So it's sine of the first, cosine of the second. It's a sum, so it's a sum. And then it's cosine of the first, sine of the second. And then evaluate. You should have all these memorized from the unit circle. Sine of 5 pi over 6 is going to be positive a half. Of course, this is still root 2 over 2, like it always is. Now cosine 5 pi over 6 is negative root 3 over 2. And this is positive root 2 over 2. So would you look at that? It looks like we're getting a positive root 2 minus a root 6 all over a 4. Whoever could have known that that was the answer? Huh. Oh, wait. Oh, I could have known that was the answer. Look at it. It fits almost perfectly on top of it. Huh. So, I don't know. Maybe that's helpful. Moving on. So 3, technically you don't do. 4 you do. 4 is a negative. So, I don't know. Let's talk for a hot minute about this, I guess. Just mostly about how would you want to break this down. And I think the answer is, do you want it as a difference or do you want it as a sum? It shouldn't matter. If you wanted to express it as a sum, meaning the sine of something plus something, then you'd pretty much end up with 2 negatives. You would be doing negative 30 plus negative 45. And that's fine. Another way to do it though is, do it as a difference. And make it so you're taking something big away from something small, so you'd end up with a negative. You got to have a 45, so use a positive 45, why don't you? And what do you got to take away from 45 to get a negative 75? You're taking away 120. Feels right. I don't really remember. This is the kind of math I'm super bad at. I'm just going to double check it. 45 minus 120. Yeah, negative 75, of course. Okay, so I don't know. I got to tell you, this is probably my preference because now I have only one negative. These are both now positive angles again. The only minus I have is just going to be the subtraction symbol in the middle of my expansion. So I'm going sine 45. I'm going cosine 120. Neither of those angles are negative. It's just the operation is a minus sign, subtraction, instead of a negative angle. And then we're going cosine 45. Sine 120. All right, again, just to be annoying, hey, where's negative 75 on the unit circle? It wouldn't happen to be right here in quadrant 4, would it? Yeah, sure, that's a 4. Seems like it would be. Now I want what? I want the sign of that. So sine should be a very negative expression. Very, very negative. So I bet that's going to be the... Well, what's the biggest thing we could ever get? The root 6 plus the root 2? All over 4? And then just take the opposite of that? I bet that's my answer, Eliza. Let's find out. So sine 45 is root 2 over 2. Cosine 120. Where's 120? 60-degree reference angle in quadrant 2. So cosine is going to be negative, and it's going to be short. It's going to be negative 1/2. Cosine 45 is root 2 over 2. Sine 120 is going to be positive, and it's going to be big, so it's positive root 3 over 2. So I'm getting negative root 2 minus root 6 all over 2. If you factor out the negative, which I would ask you to do, then it's now root 2 plus root 6 all over 4 with a factored out negative. And if you reverse these for no reason, I wouldn't ask you to, but you'd get root 6 plus root 2 over 4, which feels kind of familiar because, oh right, I just said that's what we're going to get. Because yeah, there's just not that many options. We literally can memorize them all, and you should know the answer before you even do any work, which is nice. That's a good feeling, to know what you're supposed to get before you even do the work. So then you do the work, and if you don't get what you were expecting, you can go back and figure out where you went wrong. Anyway, moving on. 5 is actually a radian one. 6 is just another degree one. I'm not doing it. Y'all can do it. 8 is tangent. So it's time to start talking tangent. This video is only 17.5 minutes long, so I won't make a whole new video dedicated to tangent. Or will I? Let's just make a whole new video for tangent. That way, if tangent's the one you need help with, you just tune in for that. Okay, bye. I'll talk to you later. Bye.